Good morning everyone. My name is Nguyen Phuong and I'm from Group 9. Our team have 4 members, Huyen as a team leader, Nguyen Trang and me and Nguyen are the team members. So today we are going to dive into an essential aspect of Linux, the boot process. Understand this chapter will help you manage the system more efficiently. Well, let's get started with the boot process. So when we press the power button on our computer, the computer doesn't jump straight to the operating system, Instead of that, it first runs a piece of code storing in a chip called by the BIOS, which stands for Basic Input Output System. The BIOS job is to initialize the hardware like the memory and hard drives before handing over the control to the operating system. And in Linux, the boot process begins when the bootloader starts loading the Linux kernel, and it ends when the login screen or prompts appear. Once the Linux is running, the system enters what we call run levels. This defines the different stages of the system and determine which services are running in the background. And now the services are the programs that work quietly behind the screen, make sure things like mouse input or display monitoring happen without interrupting user main work. In the past, Linux system used an older system called sysvinit to handle these services. However, the sysvinit had a limitation. It shares services one at a time and waiting for each to finish before moving to the next. Over time, this becomes inefficient. So to solve this, Ubuntu switched first to Upstart and then to the systemd, the default system for managing the service today. So why is systemd? I must say systemd is powerful because it can start multiple services at the same time, taking full advantage of the modern hardware. This parallel step is much faster than the old sequential method. The systemd is also event-driven, which means it can start or stop service by specific conditions are met, like when a network connection is established, etc. Well, this is a major improvement over the older system and will allowing the system to run smoother and faster. Now, as an administrator, we will need to manage user service, for example, with the system CTL, which is a command line tool for interacting with the systemd. We can start, stop, or even restart a service manually. This is very useful if you are troubleshooting an issue or need to temporarily disable a system. Well, another key element in a system administration is understanding the boot script. This script controls what services are launched when the system starts. By editing them, you can customize the system behavior during boot. Finally, I want to briefly mention the cron diamond. We help you schedule the tasks. For example, you can use this to automate the backups or updates at any specific time. This tool is very essential for us to ensure the regular maintenance that's run without needing constant manual input.
Hello everyone, my name is Nguyen Trang. Today I will walk you through the boot loading process in Linux. This process begins with the BIOS, which stands for Basic Input-Output System. The BIOS is responsible for initializing the system hardware and locating the bootloader. The bootloader then directs the system to load the Linux kernel. Next, we need to know the rule of BIOS in bootloading. The BIOS will search for bootable volume, such as hard disk or USB. Once it locates a bootable device, it reads the master boot record or MBR. This small section contains both bootloader code and partition table, as acting as a system map. With the advancement in computing, BIOS limitations become apparent. This is where UEFI or Unified Extensible Firmware Interface comes in. UEFI not only replaces by BIOS, but also improves by supporting larger devices, better security and faster boot times. Once the BIOS or UEFI have handover control, the bootloader GRUB2 in most cases takes charge. It is responsible for loading the Linux kernel into memory and starting the operating system. GRUB2 is compatible with both BIOS and UEFI systems. Now let's move to a quick demo. I will show you how to verify whether the system is using BIOS or UEFI. You can see in here I added in my Ubuntu server Ubuntu 20.04.6 long-term support, and I will enter the command. I will check if the directory sys firmware EFI exists or not, and if it exists, it is a UEFI, so I echo the UEFI, and if not, I will echo is the BIOS system, and I run this command. You can see it is Ubuntu server, my Ubuntu server UEFI. And now I will check the bootloader setting with GRUB. I will enter with the root privilege. It's super easy to do. And I specify the output file in boot group. Group. CFG. The group, as you can see in here, the group mkeyconfig will generate a new group configuration file. So this command is run successfully. I can receive this. Here is a various configuration file like group or group D, and the group also detected two Linux kernel versions. You can see VM Linux 5.50.0.1069 and VM Linux 5.50.0.1066. and it's also found Ubuntu 20.04.6 long-term support. Its installation in depth SDA1 and this configuration also includes UEFI firmware settings. Done. After the bootloader completes its task, the Linux kernel is loaded into memory. The kernel is a core of the operating system responsible for managing system resources. As users, we interact with applications, but kernel works behind the scenes, managing the application. Each object is assigned a process ID or PID. Traditionally, the Linux system would load a process called init immediately after the kernel is loaded. Init is a setter of all process, responsible for launching other essential services in sequence. This system, known as sysinit, was widely used in early Linux distributions. Now we will discuss about modern init system, Upstart and systemd. Sysinit have been replaced by more modern init systems. Ubuntu originally developed Upstart as an alternative, but it was later replaced by systemd. Systemd is now the default in most Linux distributions and is much faster because it can start processes in parallel, improving the system boot time significantly. Last, we discussed about free mode. To make the boot process more visually appealing, Ubuntu used a tool called free mode. Instead of showing a stream of system messages during boot, free mode presents a clean graphical boot screen. This improves the user experience by giving the system a polished look while loading. And now we go to a demo. Now I will show you how to verify the init system used on machine and inspect kernel messages during the boot process. First, we can check if we are using systemd by looking at the first process with the ps command. You can see in here, we use systemd. That means that the process with PID 1 in my system is systemd. And now I will view the boot messages with the dmax command. Oh, sorry, we need to use the sudo with the root privilege. As you can see, dmax is used to examine or control the kernel ring buffer, and it will display all messages from the kernel ring buffer. Because our system uses systemd, so we can also view kernel messages using journalctl with flag k. Yeah, you can see all the logs in kernel, and you can also use journalb. To see the boot logs, you can see it's journal CTL-B with journal CTL-K is quite different, quite the same, because the journal B is display all the logs in the boot. It also includes the log in kernel and something else like system service logs, user application logs, and any message logs with by demands and system component. It's the same.
So, hello everyone. My name is Jyoti, and today I would like to introduce about System D. So, what is System D? System D is a powerful service manager used in most modern Linux distributions, including Ubuntu. It was developed by Red Hat and replaced the older Sysvinit system. So, System D is responsible for managing services, starting boot, and running system processing. So to manage services in Linux, we use the systemctl command. It allows us to start, stop, restart, and check the status of services. For example, systemctl start a Apache 2 will start Apache web server, while systemctl stop Apache 2 will stop it. So let's move to the demo where we will manage the Apache web server using systemctl. First, I will show you how to start and stop the service and check its status and configure it start automatically at boot. So now let's go through the process of managing the Apache web server using systemctl. So first, we will start the Apache service by using sudo systemctl start Apache 2. We need to enter the password. So this command allows it to handle incoming web requests, and there is no error message. So this so that the command were executed successfully and the Apache service were started. So next we will verify the service status using the systemctl status Apache 2. As we can see, the active is active running. So this means that our Apache server is running and ready to serve content. And now to stop the service, we run sudo systemctl stop Apache 2 and now we will check for the status. You can see the active now is inactive. So that means the service have been successfully halted. Now we enable the Apache service to start automatically on boot with sudo systemctl enable Apache 2. So we can see this command ensures that the service will start each time the system boots up, and we see the confirmation that it has a synchronized with the system V service script. And now, if we no longer want the Apache service to start automatically, we can disable this by using sudo systemctl disable. So this command effectively removes it from the boot sequence, which is confirmed by the message indicating the service had removed from the multi-server target. So services can have a different state in system. A service can be enabled to start boot, disabled so it won't start automatically or mask it without completely prevent it from the being started. So now let's move to another demo where we will check the state of service. I will demonstrate how to list all the unit file and their state, and then show how to enable, disable, mask, and unmask a service. So let's take a look at the unit file in our system. We will running systemctl list unit files. So we have several types of unit file. The mount unit for the file system mount points, the service unit for managing the service like parties, and the part units that respond to the file system chain. So we also have system unit status. The status indicate whether a unit is enabled to start a boot, disabled, started, or generated. So for example, our Apache 2 service currently disabled. So that means it won't start automatically on boot. So let's go through a remaining comment to manage the Apache service. We will run systemctl enable Apache. We need to so you can see here we are turned to enable the Apache service, but we had an error permission denied. So this indicates that our current user does not have a sufficient permission to perform this action. Despite this error, a sibling were created, allow the system to recognize that the service should start a boot. And now we will try to disable Apache service. So the command is still successful, and we are no longer allow Apache to start automatically at boot. And now we will try the mask. So masking a service prevent it from being started manually or automatically. After running this command, a sibling will create point to deafnum, effectively disable any chain of the service starting. And now we will unmask. Finally, we unmask the Apache service. So this command to safely remove the stimling dev moon allow us to start our service again if desired. So through the command, we learn how to enable, disable, mask, and unmask the Apache service using systemctl. Each command gives us a file control over how our services operate in the system. So now let's move to the next part. In case of service failure or error, we can use Chorna CRL, Chorna CTL to check log for a specific service. For example, Chorna CTL U Apache 2 will display log related to the Apache web server and helping us troubleshoot any problem. So it's the end of my presentation. Thank you for listening.
I'm Nhan, and now I'm going to present the rest. Group risk, GR, UB rescue, and boot repair. In Linux system, we usually use GRUB or group for boot management, but the group occasionally crashes because of some common issues like missing group menu, boot failure, or incorrect configuration, or disk partition errors. And there are many tools for fixing it, like a group rescue or repair tool. And the first tool I want to introduce is group rescue. Group rescue is an essential tool for troubleshooting and recovering from boot issues on Linux. It provides CLI to diagnose and repair boot-related problems. And the second tool is boot repair. Boot repair is easier than group to than group rescue to use, but but group but group rescue is more efficient if you have uh, some knowledge and you don't have any Linux USB to fit the GRUB to fit the group, and you have to fit it by commands. And now I'm going to break the group to give you a demo how I fit the system using group rescue. A dangerous demo. This is my demo part, and now I'm going to create a new partition and set it to partition D. And because my group is set, the Linux partition is 7. But if I create a new partition, the Linux partition will be 8, and the system will be break when restarting. Now I'm going to restart. Rồi. And now the system has been prepped, and I will type ls to list particles, and I will try set command, and as you see on the screen, um, as you see on the screen, mm, mm, the root is at the 0 and GPT 7. The prefix is at the 0 GPT 7 boot graph. But if I ls at the 0 GPT 7, Yagubi fast system is a no. But if I ls uh, at the 0 GPT 8, in the system group here, fast system is the 2, because Linux Partition is now at the 0 GPT 8. So now I will set root and prefix into at the 0 GPT 8 last by the command set root equals to at the 0 GPT 8, and set prefix equals to at the 0 GPT 8 slash boot grab, enter. And now I will boot the system by the command install normal and normal. Normal. And now the system has been started, and I will boot to Linux, and to resolve it thoroughly, I have to reinstall grub here. Hello. Now I'm going to demo the boot repair tool. Now I'm having Ubuntu Live USB boot, and restart. I will start my laptop and boot to the USB. Mm, the system is starting. Okay, the system is starting, and now I will log into my Wi-Fi. And now I'm going to install boot repair tool. I will control RT to open your terminal and type sudo apt uh, repository um, ppa.yann ubuntu boot repair. Now I'm going to install a boot repair tool by the command sudo apt install boot repair. That's now the boot repair tool is installed. So I will run it by the command boot repair. And if you want to fit the group arrow, you can use recommend repair. This tool is easier to use than group rescue and uh, and it and because I fix my system by group rescue, so I don't need to use this command. And my presentation is now complete. Thank you for listening.